Today I'm going to be talking about some circuit basics, which are going to include what voltage and current are, how they're measured with the multimeter, and the application of Ohm's law. So first we're going to talk about what voltage and current are. Voltage is the force that makes electrons flow, which could be mathematically expressed by V equals dW over dQ. And then we also have current, which is the rate of flow of electrons, which is shown by I equals dW over dQ. Both current and voltage hold a place in Ohm's law, which is later applied. Before we measure voltage and current, we have to build a circuit. I built the circuit that I drew on the right sides, and I had an idea of what I was going to put on the breadboard. I made the circuit containing 3 resistors of varying resistance, a breadboard, and a power supply carrying 8.9 volts. The resistors are placed in series with one another, and they do not touch, but they're connected through the breadboard. First, with measuring voltage, we're going to set up the multimeter. There are 2 leads which have to go in 2 ports. The red lead goes in the VA port, while the black goes in the COM port. Then you're going to turn the dial to the correct setting, so we're measuring voltage. So I move the dial till I get to voltage. If measured correctly, the total voltage should equal the sum of the total voltage should equal the voltage from your power supply. So we're going to measure each voltage from each resistor, and the sum of those, which there's going to be 3, so the sum of the 3 resistors should equal 8.9 volts. As you can see here, we're measuring the voltage of each resistor. So on the left side, that's the voltage of resistor 1, and I added alligator clips to my multimeter so it was easier for me. I placed one alligator clip on the left side of the resistor and the other alligator clip on the right side of the resistor. So I did that for all 3 resistors, and I had gotten my voltages for each. So then you want to check to make sure it'll equal the total from the battery. So I did the sum, and I got 8.93 volts, which checks out. Next, we're going to measure current. It's kind of the same process as voltage, but a little different. So to set up the multimeter, the red lead goes in the VA port, and the black lead connects to the COM port. However, when you're measuring current, if you want to get it in amps, you have to move the port to where it says 10A, which is a different port setting. And then you're going to move the dial till you get to when you're measuring voltage or measuring amps. And this is called an ammeter when you move it to amps and measuring for current. Then you're going to break the circuit and then measure voltage because you're going to add the multimeter in to complete the circuit. So as you can see, this shows a better visual of what I was just talking about. So you have your multimeter, and I changed which port it was in to the 10A port. And then I also broke the circuit. So with resistor 2, I broke the circuit in between resistor 2 and resistor 3. And then I added the ammeter to one side to R2 and the other lead to R3. And so the ammeter completes the circuit, which is measuring the voltage of the whole circuit. So to wrap up, now that we know how to measure current and voltage, I briefly talked about Ohm's law. So Ohm's law is the current that flows through a circuit that is directly proportional to the voltage V applied to it. So as you can see on the right side, I wrote down what my voltages were for each one, and then I did the sum. I got 8.93, and then on the bottom is where I applied V equals IR. So for each resistor, I did the resistor's voltage equals the current, which is 0.015 ohms because I measured it in amps. And then you can see that each one I was getting like 268.7 for R3. So then the one on the right, the one that says 147.3, that is for R1. And then the 268.7 is R3. And so that is from calculating with using Ohm's law and the quantities that we measured. And so now we're going to go and see how close they were to the measured value. So here I was checking the resistances of each resistor to see if they are close to our calculated. So for R1, they're very close. We had 147.3 ohms, and I measured 145.6 ohms. For R2, I calculated 179.3, and then I measured 176.2, and then R3, I calculated 268.7 ohms, and then I measured 263. So they're all relatively close, which goes to show that it was correct. Ohm's law was applied correctly. So that is how you measure current and voltage for a series circuit with multiple resistors.